So the three similarity theorems are angle-angle similarity, side-side-side similarity, and side-angle-side similarity. Each one is used differently. So the first one I'm going to go over is angle-angle similarity. So angle-angle similarity states that if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. So what we need to show to use angle-angle similarity is we need to show that two angles are congruent to another two angles. So in order to do this, you have to examine the picture and see what information is given to us. So if we see here, we have these markings on the angles. When they're both marked with one arc, that means they're both congruent. So in looking at this, we can say that angle A is congruent to angle D. And for every statement that you give, so this is a statement, you have to give a reason. So the reason why we know those are congruent is because it's given or it's marked. Okay, likewise, we can say that angle C is congruent to angle F for the same reason. That's also given to us. So to show angle-angle similarity, that's all you need to show. You just need to show that two pairs of angles, so the first pair is angle A and angle D, and the second pair is angle C and angle F. Once you've shown that, then you can say that the two triangles are similar by angle-angle. And then we need to write a similarity statement. So the way we write the similarity statement, like we saw in the previous page, we just match up our corresponding angles. So triangle ABC, so for the first triangle, it doesn't matter the order. You just need to make sure when you write the second part of your similarity statement, you match it up. So we went A, B, C. The angle that matches up with A is D. Then we're going to go E, F. So this is going to be triangle DEF. Now we're going to go back to the front, and now we're going to talk about side-side-side similarity. So side-side-side similarity states that if all three pairs of corresponding sides of two triangles are proportional, then the two triangles are similar. So just to remind you, when we say that the sides are proportional, it means when we set up our ratios of the corresponding sides, those ratios are all equal. So for these ones, in order to show this, what we need to do is we need to match up our small, medium, and large sizes. So we're going to match small, medium, and large. That's how we know which sides we match with what. So in looking at my first triangle, 3 is a small side, 4 is a medium, 5 is a long. And then in the bigger triangle, 6 is the small, 8 is the medium, and 10 is the long side. So now I should know that I'm going to match up my small with small, medium with medium, large with large. So if you look at these triangles, we don't know anything about the angles. That's how you should know that you're probably going to be using side, side, side. Okay, so in setting up our ratios, like I said before, it doesn't matter which one you start with. So I'm going to do 3 over 6. We're going to check if that's equal to 4 over 8 and check if that's equal to 5 over 10. Okay, so what I did here is I matched up my small with my small, I matched up my medium with my medium, and I matched up my large with my large, and then I set them up as ratios. So there's my large, there's my medium, and there's the small. So when we put these all in our calculator, these all simplify to 0.5. And since those are all equal, they're exactly equal, we would say that they're similar by side, side, side. Then we can go ahead and write our similarity statement. So we can say triangle, let's just mix it up instead of ABC, let's say CBA. So when we write our similarity statement, we need to make sure we match up our corresponding angles. So I went C, then B, then A. So the way you can think about it is I started with C, which is made up of the large and the medium side. So the large and the medium side make up angle E. So we're going to start with angle E, then we're going to go to angle D, then F. So E, D, F. So triangle CBA is similar to EDF. So the last theorem we're going to talk about is called side angle side, and side angle side is kind of a mix between angle angle and side side side. So side angle side states that in two triangles, if a pair of corresponding angles are congruent and the sides including the angle are proportional, then the triangles are similar. So what we mean by including the angle, if we look at triangle ABC, we see that angle B is formed by the 12 and the 9. So we would say that angle B is the included angle between 12 and 9. Similarly, if we look at the smaller triangle here, angle E is the included angle to DE and FE, the two sides that have measurements. So that's what we mean by included. So for instance, if this 12 was on AC, we could not say this is side angle side. That angle has to be sandwiched between the two sides. Okay. So the reason I say that this one is like angle angle and side 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 is because you kind of need to do a little bit of both. So the way it's like angle angle is we need to say that we have a pair of congruent angles. Well, we see that angle B and angle E are congruent because they're marked. So that's the first thing we're going to say. So angle B is congruent to angle E, and the reason it's marked or given, whichever one you want to say. The other way, or the reason why it's like side, side, side is because you still have to check your ratios. And we're going to match them up the same way we did before. So the small needs to go with the small, and the medium needs to go with the medium. We don't care about the long side because it doesn't matter. We don't know what the long side is. So I'm going to match up my small and my medium. Okay, so it's going to be 9 over 3. So those are my smalls, equals 12 over 4. Well, when you simplify that, 9 divided by 3 is 3, and 12 over 4 is also 3. So since those ratios are equal, we would say that they're similar by side angle side. Okay, and like we've been doing, if we know that two triangles are similar, we can write a triangle similarity statement. So we can say triangle ABC is similar to triangle, and again, we got to match it up. So we went A, B, C. That's going to be similar to D, E, F. So now we're going to look at a couple more examples using angle similarity. So looking at example 1, it states, are the two triangles similar? If so, state how and write a similarity statement. So the first thing you should do is just look and see what information are you given. Well, we're given that angle E is congruent to angle Q. The reason I know that is because they have the markings on them. So the reason that we would write is just given. Okay, once you have written down all the given information, then you need to start thinking about some other things we have learned. So if you remember last week, we talked about angle pairs. When we have lines that cross, we end up with vertical angles. Vertical angles are across from each other, and we know that vertical angles are congruent. So since vertical angles are congruent, that's our second pair of congruent angles. So to name these angles, you can go ahead and just write that angle R is congruent to angle R. And the reason for that is not going to be given because it wasn't given to us. These are vertical angles. So our reason is going to be that they're vertical, or they're vertical angles. So once you show that two pairs of angles are congruent, we've proved that the two triangles are similar by angle angle. So you would just write similar by angle angle. And then writing our similarity statement, triangle FRE is similar to triangle. So I started with F, and then I went to R, and then I went to E. So the angle in the other triangle that corresponds to F is going to be P. So the second triangle is going to be PRQ. Okay, let's look at another example. So here's example 2. So example 2 asks the same thing. So again, start with the given information. So if I look at the given information, I don't see any pair of congruent angles. So right away, I'm going to actually say, oh, okay, so we know we have vertical angles here. Well, we don't know much about the triangle up here, okay? But what we do know is that there's 180 degrees in a triangle. So since we know there's 180 degrees in a triangle, we can add these two angles up. subtract from 180, and that's going to give us this angle. Well, if we know this angle, since it's vertical to this one, we'd have the other angle, and then we can do the same thing in this triangle. We could take 86 and that angle, add them up, subtract from 180 to give us angle G, and then we could see if we have two pairs of congruent angles. So here I'm going to add 87 plus 43, which is 130, and then I'm going to do 180 minus 130, which is 50 degrees. So this angle right here is 50 degrees, and like I said, since these are vertical, I know that that's 50 degrees, and then I'm going to do the same thing. I'm going to add 86 plus 50, which is 136, and I'm going to subtract from 180, and that's going to give us angle G. So 180 minus 136 is 44 degrees. So now when looking at my two triangles, I have one pair of congruent angles, and that's the vertical angles. Okay, but if we compare our other angles, we have 44 and 43 and 87 and 86. So even though they're close, they're not the same. So in this case, these triangles are not similar. So we would say not similar. And we need to write a reason. Well, the reason is they only have one pair of congruent angles. So the work I need to see for this type of problem is the work that shows me that you solve for the missing angles, and then you need to write that they're not similar, but you need to say why. There's only one pair of congruent angles. Now let's take a look at example 3. So example 3 states, are the two triangles similar? If so, state how, and write a similarity statement. So if we look at these two triangles, okay, there's the small triangle here, and then there's the big one. So since these triangles overlap, what I'm going to have you do is I'm going to have you actually draw them separately. So looking at the small triangle, okay, that's EDF. I'm going to draw that here. So EDF. And then I'm going to go ahead and take the big triangle and draw that separately. So that's going to be HFG. Your drawing doesn't have to be perfect. You just need to make sure you label it correctly. So here's HFG. Okay, then we should fill in the side. So in the smaller triangle, we have 10 is ED. And then we know DF is 13. Okay, and then EF is a little bit tricky because EF isn't given to us. What we know is that this big long side is 98, and this part right here, HE, is 84. So to figure out the length of EF, we're actually just going to subtract. So this is going to be 98 minus 84, and that's going to give us 14. So EF is 14. Okay, in the bigger triangle, HF is 98, GF is going to be 91, and then we have HG, which is 70. So once you draw your triangles separate, now it's a little bit easier to match up your small, medium, large. So just like we did before, small needs to go with small, medium goes with medium, and long goes with long. So in this triangle, 70 is the small side, 91 is the medium, and 98 is the large side. So now we're going to go ahead and write our ratios. Okay, so 10 over 70, we need to check if that's equal to 13 over 91, and check if that's equal to 14 over 98. Something I should point out now is, even though it doesn't matter if you start with a smaller triangle or the bigger triangle, when you're writing your ratios, you need to make sure the numerator or the top number is all coming from the same triangle. So 10, 13, and 14 all come from the smaller triangle. 70, 91, and 98 all come from the bigger triangle. So once your ratios are set up, go ahead and put those in your calculator. Well, if you put those in your calculator, you get a decimal, and it's about 0.14, but they're all 0.14. So since these are all 0.14, that's what we're looking for. So we would say, yes, they're similar by side, side, side. And this is the work I would expect to see. So then we need to write our triangle similarity statement. Okay, I'm going to start with my smaller triangle. So I'm going to say EFD. So here I went EFD, and that's going to match up with HFG. Okay, now we can go ahead and look at example 4. So this one's pretty straightforward. This one, we're given our two triangles, but there's nothing extra we need to do. We don't need to draw them separately. We already have all the measurements there. So here's how I know that this is probably going to be side, 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 as long as the ratios are equal, is I don't see any information about angles. When there's no information about angles, you should be thinking it's side, side, side. So just like we've been doing, okay, we're going to match up our small, medium, large. So looking at the smaller triangle, 9 is small, 12 is medium, 14 is large, and the bigger triangle, 18 is small, 24 is medium, and 27 is large. It is very important that you do this correctly. Otherwise, there is a possibility you're going to get a wrong answer. Okay, so once I label my sides small, medium, large, we're just going to go ahead and match them up. So 9 and 18 go together. 12 and 24 go together. And then 14 and 27 go together. So next, just put those in your calculator. So 9 over 18 is 0.5. 12 over 24 is 0.5. So far, so good. But if you put 14 and 27 into your calculator, it's about 0.52, which is not equal. So in that case, these are not similar. So you would write that they're not similar. And then you need to state why. Well, they're not similar because the sides are not proportional. So in order for these to be similar, this last ratio right here would have to make 0.5. But since it doesn't, we would say that they're not similar. Okay, our last two examples are example 5 and example 6. So example 5, here are two triangles, and here's how you know if it's side, angle, side. If you don't have information about the angles, or at least anything that sticks out, and you only have information about two sides, you should be thinking it's side, angle, side. So since we don't know anything about UT or DE, we know it can't be side, side, side. In addition, we don't see anything here explicitly that gives you information about the angles. So yes, I see that angle T and angle D kind of look the same, but unless it's marked, you can't say they're the same. Okay, so the question is, well, where is the congruent angle in this picture? So remember, whenever we have something that looks like a bow tie or lines that cross, remember that we have vertical angles. And there's our congruent angle. So angle C is congruent to angle C, and our reason is that they're vertical. Okay, so there's our angle. Now we need to check our sides. So we need to match up the small and the medium. So 27 is the smaller, 42 is the medium, and then in looking at the other side, 117 is the small and 182 is the medium. So now we're going to match up our smalls. So I'm going to do 27 over 117 and check and see if that's equal to 42 over 182. So when I put that in my calculator, I do 27 divided by 117, I get about 0.23. And then same thing, 42 over 182, that gives us also 0.23. So since those are equal, we would say that they're similar by side, angle, side. So the angle is this vertical angle here, okay? And something to make note of, that angle is the included angle of the two sides that were given. So 27 and 42 form angle C, and likewise on this side, 117 and 182 form that angle right there. So there's the angle, and the sides are proportional. We say they're similar by side, angle, side. Now we can go ahead and write our triangle similarity statement. So I'm going to start with, let's say, UCT. So I went from U to C to T. So the way you can think about it is I moved along the medium side. So the corresponding angle to U is going to be E. So I'm going to do the same thing. I'm going to move along the medium side. So it's going to be ECD. And we're done. Okay, the last example here is example 6. So in looking at this, again, we have overlapping triangles. So the first thing that you're going to need to do is you need to draw them separately. Okay, so I have my smaller triangle here. Okay, and that's triangle FQR. And then I have my bigger triangle, which is going to be FGH. Okay, I'm going to go ahead and label what I know. So looking at my bigger triangle, so GF is going to be 77. And then we have this side, FH. Well, we don't have the measurement for FH, but we do know that FQ is 36 and QH is 27. So what we can actually do is we can actually just go ahead and add those together, and that's going to make 63. Okay, so that means FH is 63, and we don't know what GH is. And then in the smaller triangle, we know that FQ is 36, and then we don't know what FR is, but we know that GF is 77 and GR is 34, so we can actually go ahead and subtract those. So 77 minus 34, that's 43. So RF is 43. Okay, so then I'm looking at this and I'm thinking, okay, there's not enough information because it can't be side, side, side because we don't know what RQ is and we don't know what GH is. But there is a hidden angle here that is congruent. So if we look at our original picture, there's angle F. Well, if you notice, angle F is the same for the smaller triangle as it is for the bigger triangle. Okay, we call that a shared angle. So angle F is actually our congruent angle because they're shared. So we would say that angle F is congruent to angle F, and the reason is it's shared. So there's our congruent angle. Now all we need to do is check our sides. So again, I'm going to match up my smalls with my small. So 36 is small, 63 is small, and then medium with medium. So I'm going to do, let's see, 36 over 63, and I'm going to check if that's equal to 43 over 77. Well, when we put that in our calculator, we get a subtle difference. 36 over 63 is about 0.57, and 43 over 77 is about 0.56. Since that's not equal, we would say that they're not similar. And our reason is because the sides are not proportional. So even though 0.57 and 0.56 are very, very close, it has to be exactly the same. That's why I would say they're not similar.